What's up, YouTube? So I thought I would make a video. I've been watching a lot of Mosslack's videos, and he just does pretty much a daily update of what he's working on his workbench. And I was about to get started on a new project, so I thought, well, I'll make a video documenting it. I usually just make videos that I would want to watch myself, and I figured that this might be something that in the future I would want to go back and watch. So yes, I'm going to start on a new project. As you guys know, I have tons of projects, and I always tell people my motivation level is like a roller coaster. It comes and goes with different projects, and I got motivated to start a new project. You know, what really got me into electronics as a kid was robotroom.com and David Cook's book, Robot Building for Beginners. So I always enjoyed autonomous robots, or building robots that have automated features. And this sandwich-inspired robot from David Cook actually ran off an Arduino, and this followed a line on the floor. So, and I have video of this on my YouTube channel if you want to go back, but basically you put black electrical tape up against a white background like linoleum, and these sensors can detect the black electrical tape, and it follows that line. And then another project I did, which I have a YouTube video documenting it afterwards, after I did it, is this inductive guided robot that follows inductive guidance. So it follows a wire, yeah, it just follows the wire. And I want to, so those are two ways to build robots: line following and inductive guidance. And there's another way robots can navigate called dead reckoning, which the way I'm going to explain it, my terminology of it, is that dead reckoning is when you calculate you navigate to a position based off of knowing your starting position and collecting data local to the robot. So the other way to do it, the opposite way to do it, it would be like a GPS system, where you're triangulating your data through other means, if that makes sense. So like on these, the other means would be the wire in the floor, and the other means would be electrical tape. But in dead reckoning, there is no wayside usage. You're just calculating your position because you knew your starting position, and you're collecting data off the robot through encoders and whatnot, gyros. So I'm gonna, just as a challenge, I'm gonna build a robot that uses dead reckoning. So yeah, so that's what this video is going to be about. I went and I tried a new thing where I mount my let me see if I was in, oh, I was probably off the screen a little bit there. I mounted my camera up on the rafters up above my workbench, and I do have my wireless mic hooked up to the camera, so hopefully I'm getting good audio. This mic system uses 2.4 gigahertz, and it's a kind of a cheap system, so sometimes Wi-Fi will cause interruptions. So hopefully that's not happening. And if you hear any weird background noise, it's because my neighbor is putting a new roof on his house, and looks like he's more in the demo stage, and he's doing it himself. You know, roofing guys could do that roof in one day, and in one day he's just pretty much torn all the roof off. So yeah, that's what this video is going to be about, and it'll be multiple parts. and who knows how long it'll take. It might take 2 years to complete, but it's just something I felt like doing, a project I felt like doing now, and I thought I would document it. So how do we get started? So I have my own way of doing things. I didn't go to college, so I don't have an engineering degree. So I just have developed my own way of doing things. And like I said, my biggest influence in electronics was David Cook. And his books, both the beginner one and intermediate ones, a little outdated because the electronics hobby, have really changed a whole bunch with Arduino and YouTube, and there's just a lot. If you read his, especially his beginner's book is probably pretty good for basic electronics, but his intermediate book, it's still pretty good, but he does things in that intermediate book because at the time they didn't offer a whole bunch of kits like they do. Like you can get a kit for pretty much anything, like line following robots. You can get a kit for even inductive guided robot. There's one company that builds a kit. I forget what. When this got posted on Hackaday.com, someone said, "Oh, you can buy a kit to do that." So, like I said, I have my own way of doing things, and because I really don't know how to use CAD, and I have tried experiment with CAD a little bit in the past, but the learning curve for CAD outweighs its usefulness. So I like to do hand-drawn schematics. Now, the only disadvantage to not knowing CAD is when I etch my own circuit boards, I design them in Copper Connection. And Copper Connection got bought out and you can't get it anymore. And unfortunately, I didn't buy a license. I wish I would have bought a license for Copper Connection so I could convert Copper Connection to Gerber files. But on my last project, when I was making multiple circuit boards, I found a fellow ham. I went into the Copper Connection's old Yahoo group. First guy I found, I asked him if he would convert a Copper Connection file into a Gerber file, and he turned out to be a fellow ham, and he had no problem helping me. So that was cool. So yeah, I hand draw my schematics. If I want to make a printed circuit board, I use Copper Connection. I etch it on my own. But in my development process, I usually make my own development boards. So in the past, I have used solderless breadboards. But the thing is, on a project like this, where I'm going to be adding a whole bunch of accessories to the microcontroller, that solderless breadboard is going to get really complicated really fast. And in the past, I found just keep on adding stuff. Solderless breadboards are unreliable. You know, you end up having a wire pull out and you don't realize it, and you think you have a problem with something else, but it's really the wire pulled out. So I always like kind of making my own development boards and point-to-point soldering them. That way you know you have good solid connection. And I have a stack of old boards here just to show you some of my work in my past. This is for my animatronic. This was another experiment for my animatronic. This one is the recipe board, if you guys are familiar with that. This is a really old development board, and as you can see, this one uses a 644, which is an old chip. If you're going to use a 40-pin chip, I usually use a 324. And I've used this for experimenting with several things throughout the years. And the last one I used it for was to develop the circuit for the inductive guided robot. I did all my development and experimentation on this board, the microcontroller, and it used to have an LCD screen. This one's the oven board. You see, this one uses a 324. And this one is to control the 3-axis servo skull that I have. And as you can see, I robbed parts from it, but that's what this was for. And back when Radio Shack was open, I used to always use Radio Shack boards. And so these are single point Radio Shack boards that I use. And then I bought these boards off of eBay, and I really liked them. They have 5 holes connected in line, and it kind of makes your soldering job really neat. Actually, like, let's see, which one? Oh yeah, this one is look how clean that came out. That's a really clean board for point-to-point soldering. So anyway, when going on another rant here, so when Radio Shack went out of business, which I kind of miss Radio Shack, because if I need a resistor, and it's a Saturday, you used to be able to drive out to Radio Shack, grab a resistor, and go back home, but you can't do that anymore. So you got to pretty much order everything. But when Radio Shack went out of business, I picked these up for pennies on the dollar. Double-sided circuit boards. This was a double-sided circuit board that I cut up. But I'm running into a problem with these. I don't know if it's a bad batch of boards or the fact that they're staying in my shed here. But I went to start this project using this circuit board. And I go to solder on the chip. The pad lifted off. I was like, okay, maybe that's a fluke thing. So then I do another one. I ended up having 3 pads in a row lift off. So I don't know if it's the humidity of these being in my shed, but as soon as you heat up, these pads lift off. They don't want to stick. So, and I was just using this. Like I said, I got these off of eBay and was like, wow, these are a lot better to use and they're cheaper. Got them off of eBay, but I didn't have any left over, so I wanted to use this, and then the pads lift off. So that was a big disappointment. So I went and I bought more off of eBay. But I'm going to start stuff like this. I don't leave in the shed here because I don't know if it's the humidity in the shed here. So yeah, I'm going to build up this development board today for this project using this breadboard right here. So let me move all this out of the way. Oh yeah, so another thing I want to point out while I'm going on this rant, kind of keep these stacked in the corner. So I might zoom in on this video. I don't know how well you can see this, but so here's my schematic. Basically, we have the microcontroller. I'm going to plan on starting out running it on 8 megahertz with the internal RC clock on the microcontroller. So I don't need any crystal oscillator circuit. We're going to have the ISP header wired to it so I can program it easily. And we're going to have an OLED module like this. So this is another example. I've used this board for multiple purposes, and right now this board has a dedicated purpose for a project I'm doing. So I can't use this board, but the weird part about this board is I use this board for multiple purposes, and I like using these OLED screens. And I was using this board, OLED screen was working fine, and then all of a sudden the OLED screen stopped working. But it might be the code on this board. I had a weird problem where the way I was running the interrupt routine on this code, that it was hogging up the main loop. Like you couldn't run anything in the main loop. But even before the interrupt routine on the initialization, the LED screen stopped working. But then I noticed that these pins might have been walled out. And that might be why the LED screen stopped working. But then also I found out with Atmel Studio, the new one, you can't declare your processor speed in your code. You gotta declare it in the project settings, or it doesn't render that well. And I try to not copy and paste code because I want to understand everything in my code. So I have developed my own I2C OLED routine, But when I build this new one out, I'm going to go through it and make sure I'm doing everything right, because I think my OLED library isn't that efficient. I think I'm not using the delays right for the I2C. So yeah, so this development board I'm going to solder up. Basically, just to start off, I'm going to have a microcontroller with an OLED screen, and I'm going to go and program it, and I'm going to take extra time and go back and check all my OLED code to make sure it runs right. Because like I said, using these OLED screens, they've worked fine. I used it on the recipe board, and it worked fine here until now. It doesn't work at all on this. So something went wrong. And that's pretty much what I'm going to do today, and what this video is going to be about, me making that. Oh yeah, I'm just going to add a power LED in, and I'm going to add a button for the reset of the microcontroller, because I found in the past that is useful. Because that's useful, just having a reset button. Another thing I was going to tell you guys about, when it comes to, so this Radio Shack board, the pads were lifting off instantaneously. This was made off one of those Radio Shack double clad boards. This was my last major project that spent over a year in development, and I ended up actually, this is the board design that I ended up getting the Gerber files for and having them professionally printed. But on this board here that I etched, this is a Radio Shack board that I got when Radio Shack was going out of business. I had problems with pads lifting up too on this board. Now, this board was sitting out here in the shed, so I don't know if the humidity is causing the pads to lift up. And this one I even tinned. That's the first time I tinned a board, so the copper doesn't corrode. Which the tinning is very expensive, but you hardly use it. It's very expensive for the bottle, but you hardly use it, and then you dump it back into the bottle. But yeah, that's what I was just going to say, that this board that I made, I had problems with the copper lifting up. As you can see, I filled in traces here, but I thought it was just because of my etching, but I'm starting to think if it's because of these boards sitting in the shed here. So anyway, that's enough rambling on. I probably won't film. I'm not going to film me soldering, because that's going to make this video a lot longer than it already is, since I've been rambling on. But I thought I would just share what I'm doing on my workbench today. So let's get to it. Okay, I'm all done. My tip on my soldering iron is getting a little ratchet. I started off, I took my Dremel and grinded it down, so I ordered a new tip for my soldering iron. I started off at 700 degrees, and that seemed a little hot for the wire, so I knocked it back to 680. But hopefully if I get a new tip, and I still had a little problem with melting on the insulation on the wire, but 680, if it has a good tip, should have been perfect. So yeah, it's all done. It came out pretty neat. Got my reset button right here. Got my power LED over here for the power. I put a 0.1 UF capacitor in for the micro controller, just for a little power filter. I guess I didn't explain this, but at this point I'm just going to be powering the circuit off the 5 volts coming off the USB Tiny, off the ISP header. It did get the SDA and the SCL. What's SCL? Yeah, SDA and SCL pins for the OLED screen. They crisscross over, so I went and I put a little. I used the leads from the pull-up resistors, and I crisscrossed them over into the microcontroller. and then I put heat shrink around the leads before I did that. So we'll just do, I'm pretty confident in all my solder joints. So, oh yeah, so you can take a look at that. So yeah, it came out pretty good. Like I said, if I had a better tip on my soldering iron, which I ordered, they should have came out better, should have flowed better. But I think I have good solder joints all the way around. We'll go and do a quick continuity check. Here, I'll lay this down here. I don't know if you can see it. Okay, we just want to double check the I2C. So in between the two pins, we are reading the resistor, which means there's a short because we should be reading double the resistance. So somewhere in here, let's see, 5 volts. So this line and this line, 3.4. So that tells me we don't have a dead short. But we do have a short. Okay, this should be a dead short right here. It is. This should be a dead short right here. It is. And then this should read, it's reading 4.6, but it should read double that because we should be going through 2 resistors. Let me double check that. So when I go between here, it should be going to both resistors, but it's not. It's going through 1. That means we do have a short somewhere. Unless it's the way. $3.4K. 3.4K. It might be just the OLED screen. But you know what? We can double check that using this one right here. This one's reading 1 mega ohm. Houston, we have a problem. So that's not, it's definitely not there. If it's making contact, it's making contact right here. So let's see if that changed it at all. 4.6. Dead short. $4.6K. Let me read it on this side. 6K. But remember, this one wasn't working that good. So I actually, my recipe board is here somewhere. One of these boards. Right here. 3.1K. So actually the recipe board is reading the same thing. 6K on the... Yeah, that's kind of weird. I think at this point, okay, let me check the power and ground rail, 5 volts and ground. It's good. At this point, I'll just hook it up and see if we can get it to work. Maybe there's something weird going in between on the OLED screen. Physically, they shouldn't be shorted out. So, okay, time will tell. Okay, it turns out that there was no reason to get all worried about the connections, because all the connections were fine. I hooked it up to the USB Tiny, programmed it, and worked first time. So this is all your base are belong to us is like my little hello world. Every time I use the LCD screen, I use that phrase. And when I push the reset button, it just prints it back out. Pretty solid. These LED screens are really nice. I might try to figure out how to do image. There is a way that you can bitmap a whole image to it. But yeah, everything worked out great. And I went over my code, and this shows how long it's been since I worked with this kind of stuff. 2-wire interface, or I2C, doesn't rely on any delay commands. There's absolutely no delay commands. You use a while loop and you check a bit in one of the I2C registers. So the code is actually really efficient. Now the thing about it is, I'm going to be experimenting with this project on a magnetometer, I believe it's called, and it's going to use I2C. So I'm going to have 2 devices on the I2C bus. So we'll see how that works out. But yeah, I thought I would just make this video showing some of the electronics projects I like to do. And when I go and I start experimenting with other things that I'll be adding to this board, I'll make a video of that. Hope you enjoyed this video. See ya. And I did figure out how to draw images. It was pretty easy. I used a program called LCD Assistant to convert bitmap into the code needed to draw an image. Okay, so this is the real ending of the video. Thanks for watching.